All right, so today we're looking at arithmetic sequences. So just in the beginning chapters of 3A and B, we looked at sequences. So it's when you have a number and maybe a pattern's happening. So we looked at recurrence relations. So that means the same thing is happening every time. And the way you get the next term is you do the same thing. So you can see here in this pattern, we've got plus for reoccurring, so it's a recurrence relation. But what we're going to look at in particular now is arithmetic sequence. Now, arithmetic sequence means when you're adding or subtracting the same amount every time. So you're not multiplying. So see how we're adding 4 every time. So this is an arithmetic sequence. If we were subtracting the same number, that would also be an arithmetic sequence. So what we call that bit that's getting added or subtracted, it's often called the common difference. So they'll call it, when you're going to see some formulas in a little bit, and they'll call it the D, capital D. And that's the difference. That's the bit that's getting added or subtracted every time. Okay, so the way you can find out what's happening is you could take the term in front and you minus the term before. So when we do that, we see that we get 6 minus 2 is plus 4. And that's how you can work out the common difference. So here you can see they've used term 1. So say that was term 1 and term 0. But it doesn't matter when you use it. So see, this is term 2, term 3, term 4. If I did term 4 minus term 3, I would also find out what the common difference was. So you can see it's still 4, okay? So down here in this these examples, it says find the common difference in these sequences. So all you have to do is, all right, I'm going to take 5, that term, and I'm going to subtract the term before. So it's 3. And if you check, it should work when you do 8 minus 5, which is also 3. So D, the common difference, is a positive 3. Now, if you look up here, so say that's T0, T1, T2. So we know we can find the common difference by taking a term and then minusing the term before. So here we've got 23, and we're going to minus 25. So the common difference ends up being negative 2. Okay, so it doesn't matter, even though you can have the difference as a negative number, it still works. You still minus that same term in front by the one before it. Okay, so find the common difference in this arithmetic sequence and use it to find the next term. So all you have to do is, all right, we're going to find the common difference. Just take a term in front and minus the term behind before it. So 31 was before 27. So if you do 27 minus 31, that equals negative 4. So you now know the common difference. Just double check it. Use another one. So you might say 19 minus 23. Yep, that still equals negative 4. So it is the common difference. So then, to get the next term in the sequence, so the next term is going to be 11 minus the common, the common difference, which is negative 4. So it's going to be 7. So the next term would be 7. What would the next one be?
3.
Yeah, 3. Good. Just to recap, so when you see the word arithmetic, that means that the sequence will have a common difference, okay? And that means it'll be adding or subtracting an amount, okay, in the sequence. Always adding or subtracting. Okay, so here we've got a sequence. It says 4, 7, 10. And it's an arithmetic sequence with a common difference of 3. So you can see that. You can see that we're adding 3 each time. Okay, it says construct a table showing the term number. So this is actually means this is T0, this is T1, T2, so on. And it says, and write the first 4 values of this sequence. So we can see up there that they started on 4, and T1 was 7 and T2 was 10. And then if we add another 3, that would be 13. Because they're just saying the first 4 terms of the sequence, we're going to say, in terms of the sequence, T0 is a term. So we only have to get to T3, really. Okay, now it says use it to plot the graph. So in your notes, I've already put the graph there because I just didn't want you to spend too much time like drawing up the graph. But when you know, so obviously you have, this is the term number along here, okay? And maybe you just write over here that this is the actual value of the term, okay? So you can see when we plotted this one, so you can see 0 was 4, term 1 was 7. So you can see you've got the lines there. So what you're going to notice with an arithmetic sequence, can you see if I join those dots, what type of line do I get?
Linear.
Yeah, a linear, good, oh, sorry. It's, no, don't worry about saying all that stuff. It's exactly a linear line. It's a straight line, isn't it? So a straight line, that's what linear means. So you pretty much just need to know you see a straight line. So that's what you need to make a little comment about. So maybe write a little note here. So an arithmetic sequence will produce a straight line graph. Okay, so because this one was adding 3, it went up. If you were subtracting 3, the line would go downwards, but it would still be a straight line. So if you see a straight line in a graph and they say what type of sequence is this, you'd say it's an arithmetic sequence because it's a straight line. Okay, so let's just go over a little summary. So an arithmetic sequence is generated by adding or subtracting a fixed amount to the current term. An arithmetic sequence, the common difference is the difference between 2 successive terms. So even if you want to find that, so you can find by going, say, T2 minus T1, or, you know, T3 minus T2, okay? Just put a little example so you know that. The graphs of the sequence, the points along a line with a positive slope. So say when the D equals a positive number, let's just write it in words we understand. It means the graph will be a straight line going up. When the D equals a negative number, so that means you would be subtracting, you're going to see a straight line going down. Okay?